Okay, good. So we can move on a little bit. We can move on to how we deal with binary numbers in computers. How do computers store and work with binary numbers? And why specifically binary numbers? Okay, so it's kind of easy to understand, I suppose. So let's just say we have a couple of switches in a row. Okay, 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. And when I say switches, I mean like that. Imagine them like that, switches. Okay, and what's interesting about the switch is it can have two states, on and off. And as you can see on this switch, if it's off, it's on as 0, and on is 1. And so that's how we can. So that's one of the first reasons we use this, is now you can easily represent a binary number in here. Okay, do you understand? So all that is somewhere on the computer there's a bunch of switches that are switched to 1, 0, 1, 0, 0, 1, 0, 1, holding that value. Okay, so that's easy enough. So what you can do then, let's talk about something a little bit further on about how does the computer do mathematical operations with this. Okay, so you can let's just use a number, and I'm gonna start putting them all in 8s now. That's just going to be standard because that's usually how many bits are in a register, or it's a byte. 8 bits is a byte, and so we're always going to use at least 1 byte to show this. So let's say you had the numbers like this. All right, so that's, I mean, I know that this is 10. All right, and then, so, and these are within, these are just switches, remember? So if you had to pass these values through some kind of processing thing that changes these switches to move up, let's say, so next you'll have this rather in the same columns, just 3, then over here you got your 1, 0, 1, 0, and then you got another 0. So you could just do something like that, pass it through some kind of process that will shift it, and that will give you a multiplication. So in this case, we know, because that's 10, we know we'll get 20 if we shift it once, and we'll multiply it by 2 every time we shift it. So if you shift it twice, you would have multiplied it by 4, right? Because it would have been 10 times 2 is 20, 20 times 2 is 40. Okay. So there's also another process that you can pass it through. You could have, again, let's just have use our normal 10 number. And now I'm going to use four. Okay, and so there's another process that you could pass it through that does some kind of addition. It's a special circuit that does an addition, and we'll talk about that circuit. And so you pass in 2 values into the addition circuit, and you get 1 value out. And what it will do is it will do the process that we spoke about in earlier videos, where it will add these values up for you. Okay, and then you'll get that. Okay, which is 8, 12, 16, right? 10 plus 4 is 16. Okay, so these are different things that the processor will do, and we're going to talk about that more, but just using those simple things, you can do addition and multiplication in just pretty much with only using switches on a computer. I want to talk about one more thing before we end this video. I want to talk about the case. I want to go back to this one, because remember, there's a constraint on how many bits you'll have in a register. I mean, you normally get, it's normally a 16-bit register, but these 64-bit registers, these big registers, but let's just talk about 8. But in case this one, if you had to shift this out, you could see here that the value you're going to get is going to lose this 1. Okay, so if you lose the most significant bit, you're not if you had to convert this number now, you are not going to get this number times 2, because you've lost this bit. So that's called an overflow error. And it's something that occurs because we're trying to save binary numbers in a physical system like a computer, where there's an end to how many switches we can put in a row. And of course the overflow could go the other way. If you had to try and divide this number by 2, you would lose this 1. Okay, so what would happen if you lose the 1? Well, let's say the number that you wanted to divide by 2 was 9. 9 divided by 2. So because you're losing this 1, you're going to lose the remainder. It will tell you that the answer is 4. But we know the answer isn't 4 because the remainder has been lost. Okay, so that's how you will lose, and this is also an overflow, but on the other direction. So this is why we can lose data. We get overflow errors when we're doing arithmetic in machines, because of the fact that there's a finite number of registers that we can have, and when the number goes over that register and we start losing the most significant or the least significant bit, we start losing either the accuracy of the number if we're losing it that way, or we completely lose the whole value if we're losing it that way. All right, thank you. Enjoy your day.